If you're someone who has this Master Your Multiplications mountain sheet, this is not a memorization space. This is a reminder space to everyone looking at it that we need to investigate at the base of the mountain. Let's deal with that multiplicatively using number lines, arrays, and yes, I prefer the Slavonic array. Some people use rec and rec, which is usually just two different colors. I prefer the 4, and then even to larger dotty arrays. Okay, of course you would be doing this concretely first. What does 2 times anything look like? Well, when you're drawing, whatever you have, I have 1, and if I doubled it, I'm going to show it on another row, because this is designed as an abacus, the Slavonic abacus, according to these colors. So our rows are going to be horizontal, okay, so our beads don't fall down vertically. Okay, so if I have 1 and double my number, I'm going to talk and target eventually to have students show using a second bar. So we see, let's mirror that. Could be one way to talk about it. Of course, you can double the other way, but this is just being focused. Okay, doubling like on your hands, we want to see, yes, 1, that's double, but really, if we're talking about mirrors, we're seeing double, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Wait a second, half of it, 5. 4 is half of 8. That mirrorness is what we want to target to help support the understanding of doubles. Okay, doubling isn't bad. Whatever we draw, we just put it in a mirror and count everything. Oh, okay. So that symmetry is what we're building. Double, 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 symmetry, symmetry, symmetry. When we're seeing doubling on a number line, the symmetry we may be talking about is in the size of our jump. If I got to 10 and I wanted double that amount, the symmetry is in the size of that jump. 10 plus 10 gets us to 20. I have 2 10s. I have 2 groups of 10, and it still got me to 20. Where's the 2? 1, 2 jumps. And obviously, if we're doing these on number tracks, you would be having, and Cuisenaire rods and base 10 blocks, you would be having 2 of the same rod, or 2 of the same amount. Okay. Now, you never really double without having. Talk both ways. So addition and subtraction go together, doubling and halving go together, multiplying and dividing, finding groups of and sharing them out, it all goes together. So if I got to 12, one way to get there could be a 10 and a 2. Doubling that would be 2 10s and 2 2s. Whoops. 10 and a 2. Okay. See how squished this is with the big marker? I like using, on this one, I prefer using the smaller markers. I just don't have one on hand. So, multiplication mountain, finding the 2's. Well, T numbers. Those are nice. Really nice on number lines. The T numbers. Well, 110, 2 10s, and so on. So I have one group of 10. Now I have 2 groups of 10. Hopefully you're seeing where you can go with for this one. If you know the 2's and the T's, you're doing quite well, because if you get the T's, you can have it to make the 5's. Half the 10's. Half the 10's isn't so bad. We can see it linearly. There's my 10 jump. There's my half. Okay, that gets me 1, 2 5's in there. And we check, we count it all kinds of ways. On the array, the Slavonic abacus, well, you're counting 5 as being halfway to that full 10. Wait a second, all kinds of students like counting by 5's. Well, they can, but let them get focused on 5, 10, 15, 20. As you would jump along a number line. And connect it here. Both need to be connected. Always concrete first. Having, not bad. 1 set more than doubles. Well, here's the doubles. So that's the getting the 3's. Well, let's come here and get the 3's by getting 1 more than double. 1 more set. So if each set was 1 long, I would make my double long and add 1 to it. 1, 2, 3. Alright? It's more interesting when I get longer per set. If I can get my double of 4, I can just add 1 more on it to get the 3, because 2 plus 1 is 3. Always building part whole. If you're seeing it on a number line, you would do the same. If I wanted to get 3 groups of 19, let's say, well, let's get 2 19s. There's a 19. It's a 10 and a 9. So double 19 would be just like double 10 plus double 9. This is easy to show on Cuisenaire rods. So you get 2 10 rods and 2 9 rods. And then your number track will get you to where you need it to be. You can also get to show then that a 10 and a 9 will get you there. Doubling. Cuisenaire rod showing this way and then unpacking. It's fantastic for unpacking and building the part wholeness in our students. 10's less 1 in each. That's the 9's. 4 9's. Students will start counting everything. Great, let them count, 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 count. But then say, wait a second, you already like to count in tens, and don't we just count the 10, 20, 30, 40, and take 1, 2, 3, 4 away to get 4 groups of 9? I could get 4 groups of 10 and then subtract 4 groups of 1 to get 4 groups of 9. What do you notice? 40, take 4 away, leaves us 36. 40, 39, 38, 37, 36. Seeing it on the Cuisenaire rods, they would fill in 10, 20, 30, 40, and have 1, 2, 3, 4 removed. Push them all back, and it would get us down to that 36. Oh, they can show this, but you don't push algorithmic sense, because whoops, there we go. Don't let them get algorithmic. They need to be able to say this. 4 groups of 9 must be like getting 4 groups of 10 and have 4 groups of 1 less. So what was I getting? I was getting 4 groups of 1 less than 10. Every time for the 9s. And that's why that silly thing with your fingers works. 1 less than 10. Yes, you can do them with the other ones. I'm not teaching it because I didn't memorize it. Didn't memorize it because I wasn't interested in it yet. I wanted the concrete to happen first with everyone. 5s with 1 more in each set. Well, 6 groups of 6 would be getting the 5s and 1 more. 5, 10, 15, 20, 25, 30. Plus 6. 6 groups of 6 is just like getting 6 groups of 5 plus 6 groups of 1. Okay, and of course we can go the other way. Doubles the doubles. Two groups of 4. Well, that's just double. But if I wanted 4 groups of 4, I just mirror copy the mirror copy. Add 5s and the doubles for the 7s. Okay. Well, let's show 6 groups of 7, if we will. Well, no, let's do what they said. 7 7s. We can get the 5s and the 2s. Or the 5s and the 2s. You can even go the 5s and the 2s, the 5s and the 2s. 5 5s, 5 2s, 2 5s, and double 2. $25 plus 10 plus 10 plus 4. 25. Plus 20 is 40. Plus 4. This looks really familiar to folks who are working with quadratics. And the last is actually this one instead of that one. So many people think it will be the last one. Double the force. Well, then you're good. That's all you needed was to double the force. Now all the times 8 and the 8 times tables are in here. Okay? To get the 8, well, we could do all the 4s because we could do all the 2s. And to get those, we just double it. Taken care of. And that works indefinitely.